To build our wind turbine, we used a 1-liter plastic bottle, a Sharpie, scissors, a dowel rod with a diameter of 0.6 centimeters, string, metal snips, a ruler, hot glue, and a turbine stand and rotor.
Next, we began the construction of the wind turbine. We first measured the circumference of the neck of the bottle and divided it into 3, so each section had an arc length of 3 centimeters. Using a ruler, we drew a straight line down the sides of the bottle, and using the lines as a guide, we used the metal snips to cut the bottle.
With the metal snips, we cut the dowel rod into 3 6-centimeter segments. Using the ruler and Sharpie, we marked each piece halfway at 3 centimeters. We lined this mark up with the edge of the bottle and used hot glue to secure the dowel to the blade.
We repeated this process 3 times. We then attached each blade to the rotor, spacing them evenly apart so there were 3 holes between each blade.
We faced a few challenges while building this turbine. Our biggest challenge was finding the right pitch or angle of the blade. We first tried no tilt and the turbine didn't spin. We tried extreme tilt and the turbine also failed to spin. When finding a happy medium of a slight pitch forward, we experienced inconsistencies when testing the same pitch. These were a result of the stand shifting or obstruction of the wind tunnel.
To ensure blade balance, each blade was constructed using the same material and method. Therefore, they had the same size and weight to reduce vibration. Research shows that the average wind turbine blade length is 4 times the diameter of the rotor. Since the diameter of the rotor is 6 centimeters, each blade is 24 centimeters in length.
To test the number of blades, we created a second prototype to see if more blades resulted in a higher power output. We tested this prototype with both 6 and 3 blades and found that an increase in blades led to a decrease in power due to its weight. So we decided to stick to just the 3 blades. To test the wind turbine, we attached the rotor to the stand, placed the stand in the wind turbine, attached the sensors, started the fans, and then started collecting the data. We tested 5 separate variables: the number of blades and pitch of the blades, as mentioned earlier, the distance the stand was from the fan, the blade shape, and the dowel length. After running a few tests, we noticed that there were some things we needed to change. We increased stability by shortening the dowel rods. To utilize the entire wind turbine, we put the base of the stand up against the base of the fan. We tested which blade design generated the highest power by comparing our flat blade design, prototype number 2, to our curved blade design, prototype number 1. We found that the curved design generated approximately 6.13% more power on average.
Our creative and unique curved design is both environmentally friendly and cost efficient. We upcycled one PEAT number 1 plastic bottle for the blades. We used resources we already had to secure the dowel we purchased for only 86 cents. Our design can be taken apart and properly recycled after this project is over.